Hello, pre-calc students doing standard 2.02 trigonometry, starting with problem 44. 9 cosine of theta is equal to 5 cosine of theta plus 2. So I need to isolate cosine of theta and get it by itself. So you can subtract 5 cosine of theta from each side. So I'm going to get the 5 cosine of theta is going to cancel out. And 9 cosine of theta minus 5 cosine of theta becomes 4 cosine of theta, which is going to be equal to 2. Divide each side by 4. And the cosine of theta equals 1/2. When the cosine of theta equals 1/2, we have to say, when is the cosine of theta equal to 1/2? Well, from the unit circle, cosine of theta is going to be equal to 1/2 at let's see, at pi over 3 and also would be equal to 1/2 at 2 pi minus pi over 3, so 5 pi over 3. So theta is going to be equal to pi over 3 or 5 pi over 3 in radians, or if we're in degrees, and actually it's asking for our angle in degrees, so we can do it in degrees, it would be equal to 60 degrees, or 360 minus 60 would be 300 degrees. And what we can do is use our calculator to prove it. So when is the cosine of theta equal to 1/2? Let's say, what is the cosine of degree? Is the cosine of 60 1/2? It is. Is the cosine of 300 equal to 1/2? Yes, it is. Okay, so those are both correct. 60 degrees or 300 degrees. Alright, -3 times the tangent of theta equals -√3. What we can do is divide each side by -3. -3's cancel out, and you'll have the tangent of theta equal, the negative signs will cancel out, √3 over 3. Okay? And this, if you could also write this out as, is also equal to 1 over the square root of 3. But this is going to be equivalent to, in radians, from the unit circle, when the tangent of theta is equal to √3 over 3, from the unit circle, theta would be equal to either pi over 6 radians or 7 pi over 6 radians. And in degrees, which was it's asking, that would be equal to 30 degrees or 210 degrees. So let's prove it. In our calculator, we can do the square root of 3 divided by 3. That's going to be 5.77. And let's see if the tangent of 30 degrees and 210 degrees also produces 5.7. Is the tangent of 30 degrees 5.77? Yes, it is. Is the tangent of 210 degrees 5.773502.692? Yes, it is. So this shows that we have memorized our unit circle correctly, and that our answers are 30 degrees and 210 degrees. So that's problem 45. Solve for when 0 is equal to when theta is in between 0 and 2 pi, so this is now in radians. Alright? So the tangent of theta is equal to the sine of theta. So, hint, when on the unit circle all of tangent and sine equal. That's when theta equals 0. Hopefully that will help you conceptualize it. If not, let's break this down. We can rewrite the tangent of theta as the sine of theta over the cosine of theta, and this is going to be equal to the sine of theta. All right. So then we can divide. We can divide each side by the sine of theta. If we divide this side by the sine of theta, we are, dividing by the sine of theta is the same as multiplying by 1 over the sine of theta. Maybe that will make more sense to you all. So we multiply by 1 over the sine of theta. So the sine of thetas will cancel out. So you get 1 over the cosine of theta is equal to 1. Alright, and so in this case, multiply each side by the secant of theta. If you, multiply each side by the cosine of theta. Cosine of thetas cancel out. So 1 is equal to the cosine of theta. And when the cosine of theta is equal to 1 from the unit circle, theta is going to be equal to 0 degrees. All right. But you could also say tangent of theta is equal to sine of theta. When is sine of theta over cosine of theta equal to the sine of theta? When both of these equal 0. And when does sine of theta ever equal 0? When theta equals 0, but also when theta equals pi radians. So it'd be in these two situations. All right. 4 times the cosecant of theta equals -8. Divide each side by 4. The cosecant of theta is equal to -2. So I can say, manipulating the sine over cosine, 1 over the cosine of theta equals -2. 1 is equal to -2 times the cosine of theta. The cosine of theta is equal to -1/2. And from the unit circle, when is the cosine of theta -1/2? That is going to be, in radians, that's going to be my it's going to be -1/2 in quadrant 2 and quadrant 3. So when is the cosine of theta equal to 1/2? When theta is going to be equal to 2 pi over 3. So theta is going to have to equal to 2 pi over 3 and 4 pi over 3. That's going to be in quadrant. This is our quadrant 2 and our quadrant 3 reference angle. So let's use our calculator to check. Calculator, mode. Radian mode. Let's find the cosine of 2 pi over 3. -1/2, and the cosine of 4 4 pi.
Available custodian to the gym hallway. Can I get an available custodian to the gym hallway? Available custodian to the gym hallway.
So the cosine of 2 pi over 3 and 4 pi over 3 are equal to negative 0.5. And so that's equal to negative 1/2, so that shows our values from the unit circle are correct. So this is good to go. These are our values. Now we need to use the law of sines and cosines to solve for the triangle. To solve for x here, we're going to use the law of cosines. So we have, this is a side, side, side triangle, law of cosines. Using the law of cosines, I know that so to find the angle, I know that the cosine of x is going to be equal to 7 squared plus 12 squared minus 15 squared over 2 times 7 times 12. Alright? So that means that I can do 7 squared plus 12 squared minus 15 squared. This gives me negative 32, because that makes sense. That would be 49 plus 144 minus 225. Yeah, it gives us negative 32. Divide that by 2 times 7 times 12. That's going to give us negative 1.9047. So we have the cosine of x is going to be equal to negative 0.90476. So just find the inverse cosine. So if cosine of x equals this term, x is going to be equal to the inverse cosine of negative negative 0.190476. So I find the inverse cosine of that value. Mode, triangles have degrees, not radians. So I'm going to find the inverse cosine of negative 0.190476. Let's get as accurate as possible. So that's going to give us 100.9805. So x is equal to 100.9805. So that solves for x using the law of cosines. For 49, this is going to be side, angle, side. We can still use the law of cosines. So side, angle, side, law of cosines. So we can know that x squared is going to be equal to 13 squared plus 24 squared minus 2 times 13 times 24 times the cosine of 87. And furthermore, from that information, we know that x, side x, is going to be equal to the square root of 13 squared plus 24 squared minus 2 times 13 times 24 times the cosine of 87. So x is going to be equal to, find the square root of 13 squared plus 24 squared minus 2 times 13 times 24 times the cosine of degree mode, 87 degrees. That gives us an x value of 26.69. So x should have a length of 26.69 units. Alright, that's 49. Let's do 50. For 50, we have an angle. So we have an angle we need to find in its included side, and then both the included side and the included angle. So that's going to give us a law of sines problem. From the law of sines, we know that for law of sines to solve an angle, the sine of x over 16 is equal to, remember, x is associated with 16, it's opposite 16, is equal to the sine of 115 over 49. At this point, we can multiply each side by 16, so the sine of x is equal to 16 times the sine of 115 over 49. And so that, in that case, angle x, right? Angle x would be equal to the inverse sine of 16 times the sine of 115 degrees all over 49. So we need to, in our calculator, find the inverse sine of 16, let's put this in parentheses, 16 times the sine of 115 divided by 49. That's going to give us an angle of 17.21 degrees. So angle x is equal to 17.21 degrees. Let's go to problem. Sorry about that. This is getting a little wonky. Let's go to problem 51. 15, we have 48, 22, x, and 15. So our first step is to fill in our missing angle. So this angle is going to be equal to 180 minus 22 minus 48. So we'll try to do this in our head. 180 minus 22 is going to be 158. 158 minus 48, let's do 158 minus 8, that's 150. 150 minus 40 is 110. So this angle is 110 degrees. Now, we have we know this side is 110 degrees. We have our side and the angle opposite of it, and we also have the angle opposite the side we need to find. So using the law of sines, we can set up that x over the sine of 110 is equal to 15 over the sine of 22 degrees. So to get x is going to be equal to 15 times the sine of 110 degrees over the sine of 22 degrees. So I'm going to take my calculator and find 15 times the sine of 110 divided by the sine of 22. That should give us a side length of 37.63 degrees. Equal to, oh sorry, a side length of 37.63 units. We don't have feet or inches for length, but this is length. This is the length of x. Alright, so that is problem 51. 52. Alright. The houses of Abby, Brandon, and Cliff form a triangle. If the distance from Abby to Cliff's is 1.8 miles, the distance between Abby's and Brandon's house is 2.4 miles, and the angle formed at Brandon's house is 40 degrees. How far apart are Brandon and Cliff's houses? Alright, so we've drawn our triangle. Alright, and what we need to do is investigate on how we can find our different values. So we have a side and the angle opposite of it, and then another side, and we need to find, and so far the only information that we can find out right now with this triangle is this angle right here. But from this angle we can obtain more information. So angle C is going to be, to find angle C, we know that the sine of angle C over 2.4 is equal to the sine of 40 over 1.8. So angle with that, so with this being true, angle C would be equal to the inverse sine of 2.4 times the sine of 40 all over 1.8. So what I'm going to do is I'm going to take my calculator and find the inverse sine of 2.4 times the sine of 40 all divided by 1.8. So that should give us a value of angle C is equal to 58.98 degrees. So angle C is going to be equal to 58.98 degrees. That's important. It's not the answer, but it's important. So that's 58.98 degrees. And from that information, we can find angle A. Angle A is going to be equal to 180 minus 40 minus 58.98. So we can do 180 minus 40 minus 58 point, and actually 58.99. That's, we can round it up. So it's going to be 81.01. That's going to be angle A. So angle A is going to be equal to 81.01 degrees, right? And from that, we can use angle A to find x. To solve for x, we know that, so this is 81.01 degrees. We can use the law of sines again. From this point, we can say that x over the sine of 81.01, and this is going to be equal to multiple things, but let's just do, is equal to 1.8 over the sine of 40. So x is equal to 1.8 times the sine of 81.01 over the sine of 40. And from this point, we can take our calculator and do 1.8 times the sine of 81.01 divided by the sine of 40. All right, 2.765. So x is equal to 2.765. And this is miles. M-I-L-E-S, miles. 2.765 miles. $53. If a 12-foot long ladder leaned against the house is placed at an angle of 70 degrees to the ground, how high up the house does the ladder reach? So we have a ladder leaned up against the house. We have it's leaned up against the house. The angle is placed at 70 degrees to the ground. So the distance to the ground is 70 degrees. And the ladder is 12 foot long. So that length is 12 foot. How high up the house does the ladder reach? So we need to find this length right here. So let's find the length of y. All right. So I know that the sine of 70 is going to be equal to, remember, y is the opposite side, 12 is the hypotenuse, because just in general, you must know that the sine of theta is equal to the opposite side over the hypotenuse. So the sine of 70 is going to be equal to y over 12. So 12 times the sine of 70 is going to be equal to y. So 12 times the sine of 70 degrees is going to be equal to 11.27. So that means y is going to be equal to 11.27. So the ladder reaches 11.27 feet up the house. Alright. The placement of a given car on a Ferris wheel is given by the equation f of t is equal to negative 50 times the sine of pi over 20t plus 6, where t is the time of minutes. What is the maximum height of the Ferris wheel? How high off of the ground do you start? How long does it take to reach the top of the wheel? Alright, so this one's a little tricky, so we need to conceptualize it here. F of t is time. So to find the maximum height of the Ferris wheel, we need to understand that we have an amplitude here. So I know the maximum height of the Ferris wheel is going to be the vertical shift plus the amplitude. That's going to be equal to 50 plus 6, which is going to be equal to 56. Let's say it's 56 feet. So I get my calculator. Let's make sure that we are in function mode and plot the function negative 50 times the, let's go to radian mode. Times the sine of pi over 20 x plus 6. Alright, and then my window we're going to have our, let's not change your x max or y max, but the y max is going to have to be at least 60. And then this is going to have to be at least negative 60. Alright, so let's graph the function. Alright. If we change the window even more, we can have, if the x max becomes 50, we can really see what's going on. Alright, so the maximum height is 56, and another thing we can do is we can calc a maximum. Choose a left bound point of the maximum, choose a right bound point of the maximum, and do our best guess. And we have a maximum of x equals 30, y equals 56. So we do have a maximum of 56. High off the ground, how high off the ground do you start? And that's going to be when we're going to start at 0, okay? So we're going to, if we want to just trace, we know that actually when t equals 0, the sign of 0 is 1, so this would be 50 times, so it would be 6. So how high off the ground do you start? When t equals 0, you have negative 50 times the sine of pi over 20 times 0 plus 6. This becomes negative 50 times pi over 20 times 0 times the sine of 0 plus 6. The sine of 0 is 0. So 0 times negative 50 is still 0. This becomes equal to, this means f of t equals 6. Let's prove it in our calculator. If we calc our 0, let's choose our left bound point and our right bound point, and best guess for our 0. We have a 0 at, oh actually that's when y equals 0, but when t equals 0, let's calc a value. Let's tell a value when x equals 0. When x equals 0, y equals 6. Okay? When x equals 0, y equals 6. So that's when t equals 0. Here I replaced t with x because that was x is the variable in the calculator. So at the end of the day, we can find out algebraically or with our calculator that 6 is this is 6 feet off the ground when you start. All right, how long does it take to reach the top of the Ferris wheel? So this is essentially saying, what's the top of the Ferris wheel when f of t equals 56? So to get to the top of the Ferris wheel, you have 56 is equal to, that's f of t, it's going to be equal to negative 50 times the sine of pi over 20 t plus 6. So to isolate t, we have to take 56, subtract 6, divide by negative 50, take the inverse sign of that value, and then divide that by pi over 20. The inverse sign of negative 1. So we divide this value by pi divided by 20. That's going to be about, we'll have a value of negative 10. So what we can do, so that's one method. The other method is at negative 10 we'll have a maximum. But if you just go back to our graph, what we can do is we can, so we'll definitely have a negative 10 here, but we can calc our maximum using this method, find a left-bound point, and we'll find it's 30. A right-bound point, and a point in the center. So that maximum is going to be x is 30, y is 56. So x is going to be equal to 30. So t is going to be equal to 30. All right, 30 units of time. And that's the time that it takes to get to the top. And that's because when we get to the top, our x value is 30 and 56 is our maximum. Okay, that's the video.